Welcome to YQ Academy Core Java Interview Questions and Answers. 1. What are thread groups? In Java, a thread group is a way to group multiple threads together for organizational and management purposes. It allows you to treat multiple threads as a single unit, enabling operations to be performed on all threads in the group collectively. Thread groups maintain an active count, which represents the number of active threads in the group. An active thread is one that has not yet completed its execution or has not been explicitly terminated. 2. What are thread local variables? Thread local variables in Java provide a way to create variables that are unique to each individual thread. Each thread that accesses a thread local variable has its own independent copy of the variable, and changes made to the variable in one thread do not affect its value in other threads. Thread local variables are inherently thread-safe because each thread has its own independent copy of the variable. This eliminates the need for explicit synchronization when accessing the variable from multiple threads. 3. What are daemon threads in Java? In Java, daemon threads are a special type of threads that run in the background and provide support to other non-daemon threads. They are also known as background threads. The main characteristic of daemon threads is that they don't prevent the Java Virtual Machine JVM from exiting when all non-daemon threads have finished executing. Daemon threads are typically used for non-critical tasks such as garbage collection, logging, periodic maintenance tasks, or background I/O operations. They provide auxiliary services to the main application without blocking its termination. 4. How to make a non-daemon thread as daemon. In Java, once a thread is created, its status as a daemon or non-daemon thread is determined. It's not possible to directly change the status of a thread from non-daemon to daemon or vice versa. The daemon status of a thread is typically set at the time of its creation. To create a daemon thread, you can use the setDaemonTrue method of the thread class before starting the thread. Here's an example. In this example, the mythread is created as a non-daemon thread by default. By invoking the setDaemonTrue method before starting the thread, we change its status to a daemon thread. After setting the daemon status, you can start the thread using the start method. 5. Can we make main thread as daemon? No, it is not possible to make the main thread in Java a daemon thread. The main thread is the entry point of the Java program and is automatically created by the Java Virtual Machine JVM. By default, the main thread is a non-daemon thread, and it continues to execute until the program terminates. The JVM itself manages the main thread and sets it as a non-daemon thread. The purpose of the main thread is to execute the main method of the program and initiate the program's execution. If the main thread were to be made a daemon thread, there would be no guarantee that the program's execution would continue, as daemon threads are automatically terminated when all non-daemon threads have finished. 6. Discuss the concept of thread safety in Java and provide examples of thread-safe code. Thread safety refers to the ability of a program or code to function correctly and maintain data integrity when accessed by multiple threads concurrently. In Java, thread safety is crucial when developing multi-threaded applications to avoid data inconsistencies, race conditions, and other concurrency issues. Thread-safe code example. In this example, the counter class uses the synchronized keyword to ensure that the increment and getCount methods are accessed by only one thread at a time. This guarantees the thread safety of the count variable, and concurrent access will not result in data inconsistencies. 7. Explain importance of thread safety in Java. 1. Data integrity. Thread safety ensures that shared data remains consistent and doesn't get corrupted or produce unexpected results when accessed concurrently by multiple threads. 2. Concurrency control. It allows multiple threads to access shared resources without conflicts or race conditions, ensuring predictable and correct execution. 3. Scalability. Thread-safe code enables efficient utilization of resources and supports concurrent execution, leading to better performance and scalability of the application. 8. Describe the purpose and usage of the volatile keyword in Java threads. How does it ensure visibility and atomicity of variables in multi-threaded environments? The volatile keyword in Java is used to indicate that a variable is shared among multiple threads, and its value may be modified by different threads. It ensures the visibility and atomicity of variables in multi-threaded environments. 1. Visibility. When a variable is declared as volatile, any changes made to that variable by one thread are immediately visible to other threads. This ensures that the most up-to-date value of the variable is always read by all threads. Without the volatile keyword, threads may see stale or inconsistent values due to caching or optimizations. 2. Atomicity. The volatile keyword also provides atomicity for certain operations on variables. Atomicity means that an operation is indivisible and cannot be interrupted by other threads. While volatile does not provide atomicity for compound actions e.g., incrementing a variable, it guarantees atomicity for simple read/write operations on the variable. Use volatile when a variable is accessed by multiple threads without any synchronization mechanism. It is commonly used for flags or status variables shared among threads, such as stop flags or termination signals. Example. In this example, the stop flag variable is declared as volatile. The setStop flag method is called by another thread to set the stop flag to true, which will be immediately visible to the thread executing the doWork method. The doWork method continuously checks the value of stop flag and stops its execution when it becomes true. By using the volatile keyword, you ensure that changes made to the stop flag variable in one thread are immediately visible to other threads, thus facilitating proper communication and synchronization between threads. This is the end of our Java interview questions. We hope you enjoyed learning with YQ Academy. Until another time, goodbye.